Find the standard equation of the parabola with focus minus 1 comma 4 and directrix x equals minus 4. Well, just like the last example, I want to start with a diagram. I'll admit, not entirely necessary, right? If you can hold all this information in your head, you can do it without the diagram. But personally, I always do better with a diagram. So there's my directrix at x equals minus 4 and my focus at minus 1 comma positive 4. My vertex should be right in the middle. And then I know this is going to be a parabola that faces off to the right, that opens to the right. So its equation is going to be in the format of a y minus k squared equals 4p x minus h, where I'll need to know a value for p and then the ordered pair for the vertex. Well, let's track down that vertex. I know it lies on the axis of symmetry, which means it's going to have a y-coordinate of 4. And now all I need to do is think about halfway between the directrix and the focus. So I always just like to think about an average. Minus 1 plus minus 4 is minus 5. Divided by 2 is a minus 5 halves. All right, I found my vertex. It's at minus 5 halves, or 2.5. Minus 2.5 comma 4. All right, so we have to deal with a fraction here. That's okay. I know my value of p is a distance between a vertex and a focus. A signed distance, but since this parabola faces off to the right, we're going to have a positive value for p. All right, so how far apart are my vertex and my focus? Well, I need to find the distance between minus 1 and minus 2.5, which I would say is minus 2.5 minus a minus 1 in absolute value. Minus 2.5 plus 1 is minus 1.5, so that distance is positive 1.5, which I'm going to think about as a 3 over 2 for purposes of this problem. All right, y minus k, so the y-coordinate of the vertex here, is equal to 4 times 3 halves, that value of p. So that's going to be a 6, and then an x minus, so a plus 5 halves, a minus 5 over 2. And there's our equation for this parabola.